In this lesson, we're going to set up the ratios with similar right triangles when I take a right triangle and create an altitude. We talked a little bit about this in the last unit, so now it's coming back to us. Here we have triangle ABC, and this is a right triangle with the right angle at B, and then I create an altitude, so there's another right angle at D. And like we talked about before, I can identify three right triangles. We have the big one, ABC, and then we have the medium-sized one on this side, and then we have the small one, ADB. So there are a total of three. And then let's name them. And I'll try to name them in the same order. So let's say we're going to put the B, or the right angle, in the middle. And we'll start on the short side and then the other leg. So this is triangle ABC, if I do it that way. So the big one is ABC. And then, if I do that again for the medium-sized one, again we're going to start on the short leg, so BDC. And then finally for the small triangle we have ADB. So again, our three triangles consist of the big one, ABD, the medium-sized one, BDC, right there, and the small triangle, ADB. So these are the three triangles that we can talk about. And let's see, again, we had this conversation before. I want to see if these triangles are going to be similar to each other. The first thing I want to do is draw them out down here on the side. So I'm going to draw them all, I think the same way. Let's draw the big one. This is A. This is big right triangle B, right angle B, and there's C. And then we have the medium-sized one. So this is a right angle D, and this is C, and this is B, but it's a different B than the other B. And then we have the little guy. So again, this is a right angle D, and B, and A. So for starters, we know that they all three have a right angle to them. And then what else we know, if you look at the original picture with my sketches down here, two of the triangles are going to share angle A, and the other two are going to share angle C. So between the big triangle and the medium triangle, they share angle C. So I can mark that. That means that the big triangle is similar to the medium, which is the next question, but let's talk about the small next. The small triangle and the big triangle share angle A. So that's this guy. So when it says, is the big triangle similar to the small triangle, we can say yes, that's supposed to be a Y. Yes, because of angle-angle similarity. And we can talk about the big triangle being similar to the medium triangle for the same reason, angle-angle similarity, because we showed that the right angle and then they also share another angle, and that's sufficient to say that they are similar. And then by the transitive property, we know that if two things are similar to the same thing, then they are similar to each other. So the small triangle and the medium triangle are also going to be similar. And again, that's because of the transitive property. So we have three triangles in this image, and they are all similar to each other. What we're going to do next is just practice setting up ratios between them. So when you set up these triangles by thinking about the similarity, and the triangles aren't labeled, you're going to have to think about the side legs. You've got a short side, a long side, and the hypotenuse. And that's how we're going to figure out what's going to be similar to what. So in my first example, I have this altitude here, and I have the small and the medium triangles that I'm dealing with. So if you look at the small triangle, I have a short side and the long side. So I could say long, or short over long, so it's 4 over x. those are the two sides in the small triangle. Then if you look at the medium triangle, I have the same thing. I have short over long. So this is x over 9. So let me show you again. When I set up the ratio, I have two triangles. I'm looking at the small and the medium. So if I look at the small, I have short over long and short over long for the medium. And that gives me my ratio of 4 over x equals x over 9. And then you cross multiply. X squared equals 36. Since we're dealing with side lengths, we can take the square root, and you have an answer of 6. So let's try that again for the second one here. Actually, I'm going to save this one for you to try to set up. Remember, we have the two, we have the small and the medium, because if you look, the legs of the large triangle are not being used, so it's just the small and the medium. See if you can set up the same thing. Short over medium, or short over long, is equal to short over long, and solve that one. So I'm going to do problem number 4, and you're going to set up problem number 3, just because number 4, the triangle is tilted the other way. But again, because I'm not dealing with these outside legs, I'm dealing with the little triangle and the medium triangle. And once again, short over long is going to be equal to short over long. So I have short over long side is equal to short side over long side. And if you keep doing these, this is our fourth example. Once you do the third one, you should start to see a pattern. What is happening with the altitude when I set this up? I want you to stare at that and think about it. When I solve this one, x squared is equal to 18. So x is going to be a radical 18. And as we progress further in this unit, we're going to come back and learn how to simplify that, or remind you how to write that in simplest radical form. If you remember how to reduce radicals from last year, then this is just a preview of what's coming up. You would take radical 9 and radical 2, you'd split it up into perfect squares, and the actual value is going to be 3 radical 2. However, I don't expect you to remember that just yet. We are going to get to it towards the end of the unit. So we'll look at a different type of setup with our similar triangles. Here we have, if we take a look, I have the small side, the small triangle, and now I have the big triangle. So now we're going to compare small to big. And it looks like I have the short side and the hypotenuse. And I have the short side and the hypotenuse of the big triangle. So that's how I'm going to set up this ratio. Short side over hypotenuse is equal to short side over hypotenuse. And if I cross multiply, I get 12x is equal to 36. So x ends up being 3 here. So we'll try this one more time. This one looks a tiny bit more algebraic when we get done. But let's see what it gives us here. This one, yeah, it's going to take a little bit of work. So, if you look, we're back to our small and medium triangle. I don't know why there's only one example of the other type, but we got 2 more days of this, so it's okay. Again, so we have small over long is equal to small over long. So this is going to be x minus 3 over radical 10, and that's equal to radical 10 over x. Notice again, hopefully you've seen this pattern, that this radical 10 keeps showing up in the 2 places. The altitude is showing up in the bottom left and upper right. We're going to talk more about that tomorrow. So when I cross multiply, we have to be careful because this is going to be a second degree equation now. And when I multiply a radical 10 by a radical 10, that gives you radical 100. Taking the square root, you're going to get 10. So here's what I'm going to do. I'm going to distribute, and I get x squared minus 3x is equal to 10. This is a second degree equation. So to solve second degrees, you're going to put it in standard form, and we're going to factor and set each factor equal to 0 and see what we come up with. We know that we need a positive value because x has to be positive. It's a distance. Factors of 10 that have a difference of 3 would be x minus 5. X plus 2 is equal to 0. So making my t and setting each factor, I get x minus 5 is equal to 0. X plus 2 is equal to 0. Well, this is going to be negative, so we're not going to use that one, which means x has to be equal to 5. So coming back up here, my one side is going to be 5, and the other side is going to be 5 minus 3, which is 2. So I have two answers when I have a second degree equation. And again, we're going to work on more of those in class. We're going to work on breaking these similar triangles out so you can see them better, and then you'll start to see the pattern that we build on tomorrow.